Let's get everybody on Zoom. Welcome to the class. Then we'll do our thing here in person. Alrighty, welcome in everyone. Trying to organize things a little bit better for us because I know last unit was kind of weird with half of us at home, half of us in person and switching and doing all that stuff. So I spent the weekend trying to reformat the module a little bit so maybe it's a little bit easier to understand. So before we get started too crazy today, I want to walk us through where everything is located, just because I know part of the issue last unit was just, it was just confusing where things were at, and that's on me. So I'm trying to get better at putting things in a location for you guys. So you can let me know this time if this is better, this is worse, whatever. So here's our newest learning plan for the 21st or the 28th. There's our stuff. I slid the notes back up here to the top, so you don't have to go digging down 2 or 3 modules to find it. So that should make it easier. Attendance checks for Zoom people are located right here. You probably won't see the B's because those are from my 0 period only. Now, a lot of people, and it wasn't just a couple, a lot of people in the emails were saying they didn't know where to turn in the free response questions, the worksheets, that kind of stuff. So I moved them up into this unit so you guys can find them very easily. So where you're going to turn in all your stuff is right here. So for our first couple of worksheets, after you complete them and take pictures of them, go here. Our free response questions will be turned in here. Our last worksheet for nonlinear regression would go here. And the textbook problems would go here. So hopefully this will help organize it a little bit better, and I'll just keep sliding this up with whatever our newest module is. So if you've already turned them in, you're good, and if you're not, then it'll be underneath there. And then I tried to organize the assignments a little bit better too. So the homework packet and calendar is right here, which I'm gonna open up again in a second just to show you guys all the dates for everything. The answers for the worksheets are underneath them. The textbook assignment and FRQ packet information is right here. So in a second, I want to show you guys how to register for the textbook so that you guys can do that. You don't have to do it right now in class, but I want to show you that. The answers for the book problems are located here. Oh, okay. The free response question packet is here. We'll go over the answers together in class, so they're not open yet. And then for, and I pick on Jessica because she was awesome, but there is optional extra review if you would like some. The word optional means you can or you don't have to do it. Okay, so, and this is not something that I would sit here and take points off if you didn't do it, and I'm not going to give you points if you do it. It's just completely optional if that's something you want to do. And then I'll open up these other things as we get there because we got a practice quiz and that kind of stuff. The Albert I.O. assignment is in there. So if you go to Albert I.O., all right, you go into your class, well, you guys should see your thing. And then for assignments, it's right there, multiple choice. It's due on the 1st. So let me go through all the due dates for you. And then those of you guys that are in class, you have a list here. Those of you guys that are at home, I'll show you in the packet where it's at too, so you guys can see it. But I went ahead and I put all of the due dates on, on the board, and they're in that little, where's it at? The homework packet outline here. So where am I looking? There it is. Unit 2, homework packet and calendar. So if I click in here, remember the very first day gets you what stuff is due. Ignore the A days. We don't do this class on A day. We do this class on B day. So everything for you guys is B day. So the first day we talked about the notes, we did the guessing game. Second day we talked more notes, worked on your homework. Today's the 3rd day, again, work on your homework. So nothing's due yet. Okay, so the first thing that's going to be due is on Wednesday. You're going to turn in at that one place your homework packet up to and including regression number 3. So there's 3 regression worksheets in there. Just do the first one. Got the answer keys to check if you need to. We're going to talk about nonlinear regression, and the other thing we're going to do in class on Wednesday is our practice quiz. And the word practice is important, meaning I'm not going to take grade for it. Okay, so I'm going to put a quiz in front of you. I'm going to set the timer, and I'm going to sit here quietly. You guys are going to do your quiz. You're going to see how good you get. And then we're going to go over the answers and stuff together in class on Friday. We're also going to be working on our FRQ packet because that's going to be due on the 28th because you get the day after class, not graded. So basically, you need to have your FRQ packet ready to go for the Tuesday next week because we're going to do that in class together. And then that's also the same day your nonlinear worksheet is due. So whenever you see this stuff, that should help you guys with the due dates because I know there was some confusion on it. And then all the other stuff I didn't mention, Albert.io and the textbook stuff would be due the morning of your tests. So you've got, for you guys, that's Thursday the 1st because you guys don't do stuff on 8/8. So again, there it is right there. I think people at home, I can kind of do this. Maybe you can see the same thing they're looking at. There you go. There's your list. I don't know how well it looks on your screen. But we've got homework packet due Wednesday, practice quiz we're going to do in class on Wednesday, FRQ package due on Monday by nighttime. Nonlinear worksheet is due on Tuesday, and then Albert.io and textbook review, those will be on Thursday, and our test is in class. So that should help you guys out with your stuff. Make it a little bit easier because it was my bad for not making it nice and clear and easy to read. So I apologize for confusion. I did not put in late grades for Unit 1 because it wasn't fair. If I didn't do a good job of, advertising where everything was located, then I can't sit there and take off points from you. Okay, so there we go. Questions for me, Zoom and or in-class people on that stuff? We okay with that? Or even if you're not, we understand it at least. All right, the other thing for you guys to do then, if there's no questions, is, you don't have to do this right now, but at some point when you start working on your textbook, right underneath where it says textbook assignments, I put information on how to register for the textbook. So all the other classes have done this. We're the only ones that haven't done it yet, but it's okay. There's not been like anything you're behind on. For our class textbook, we have digital copies and we have physical copies, like hard copies. There's not enough of both for everybody to have both. So kind of decide in the next couple of days what you would prefer. Just have a digital one that's easy just to log into and do your thing. Or are you somebody who likes to actually turn the pages and look at it that way? Either way is fine. But the instructions for either one are on here. If you want a physical copy of the book, then you have to go to the high school. We don't have textbooks here in this building. To the very back of the high school in house 300. If you're a virtual learner, then you just park in that back parking lot real fast. Where the house 300 is, it's the back of G Hall. And then you knock on the door between 2 and 4 o'clock in the afternoon, and Miss Clarquist, who's there, will be looking for you. It looks like a green front cover. All right, so Zoom people, it looks like this. It says Stats Modeling the World. All you have to do is say, I'm in AP Stat with Mr. G, and Miss Clarquist will know exactly which textbook you need. She's very good. She's very awesome if you've never met her before. She will not get you the wrong textbook. She's smart. So the virtual one, you just have to go to the website, which is mymathlab.com. If you have done something on MyMathLab before for a physics class or anything else, then you already have an account. Just go in there, enter your code, and you're fine. All the instructions right here. The course ID is Jennykins 65245. And then this is the code that you type in there. Do not pay for access. You get to the point where it's like, you need to pay 100. Don't pay any money because we have access to this stuff. So let me know if it's not working for you before you spend your money, please. I can think of a lot more fun things to do with $100 and something than buying a textbook. So do not spend money, okay? Zoom people, do not spend money on this textbook. Don't do it, okay? I'm not gonna put zeros in and fail you for the course because the code's not working. Do not spend money. Let me know if it's not working because I can yell at the textbook guy. We had issues last year. Tell him to get his acting gear. So he's got one job and I can make sure he does it. So either one. It looks like the same front, like when you do it. So when you click on the My Math Lab, this is what the website looks like. So if you have an account, you sign in. If you don't have an account, you click student and you go through and you create your stuff. Do you have an account at My Math Lab? So you're gonna click right here, need access, student, and then you're gonna sign in all your information. All right. You can enter the course ID program. Well, Mr. G, what is the course ID problem? Well, if I go back here, oh, that's the wrong thing. Where's our deal at? Course ID, Jenikin 65. I'm not going to type it in because I don't want to take up a registration, but that's what you would type in there. This would go into where it's at. This, and then you hit continue. I can't continue because I'll take up a code, and then you keep going, and it would ask you for the basically it's that big complicated looking password. It'll ask you for this so that you don't have to pay. So do you already have a license or do you need to pay for one? You already have a license. So you would just copy and paste this in here and you should be good to go. We told them we needed like 400 of these for all the AP students. So there should be enough. If there's not, we'll yell at them. They will pay for it. You will not pay any money. Please do not pay any money. I don't want a nasty email from your mom or dad. Well, why are you making my kid pay 100? I think it's like 170 something bucks. Don't do it. Okay. All right. So you don't have to do that right now at this moment. You can if you want to, but you don't have to. Just by like Friday, have yourself situated one way or another so you guys can start working on the review. Okay, I think that covers all of the craziness for, action items and all that stuff. So we'll talk about notes unless you guys have anything else. So textbooks, assignments, all the turn-in stuff goes right here again. So it's easy to find underneath the checks. We got our assignments here for resources if you need them. Remember, the answer keys are online for the homework to help you guys study. And then the textbook answers, problems, all that stuff's right here for you guys to study. So this gives you a list of all the textbook problems you're supposed to do. And then again, optional review, optional practice. This is not, if you got free time and you want to have some extra practice, do it. If you're like, I'm done with stats, then don't do it. Like nobody's going to hurt. I'm not going to be hurting my feelings. Okay? I just put it on there because I say some of you guys had asked for other stuff. All right, so let's finish the notes for our regression stuff for today since I don't see any questions. That way the Zoom people don't have to be online forever and ever. So we're on day number 3. We're going to finish our last example from day number 2 first, which was the minister data. I said we were going to stop right here, and you guys are going to work on this in class today to make sure you remembered how to do everything because it's been a weekend. I want to see if you guys know what you're doing. So here is your minister data. Basically, what we have here in front of us is association versus causation. In a famous example of a correlation study, the following results were obtained. So over here is just the years that they found this data. Do not type these into the calculator. Instead, type this as your X values, the number of Methodist ministers in New England, and type this in your calculator as your Y values, the Cuban rum imported barrels into Boston. So what we're looking at is as the Methodist ministers increase, so does the amount of rum people are drinking. What's our strength there? Are these ministers stressing people out? What do you think, Laura? So what do you think? The ministers stressing people out. Anybody need a computer to look at notes? All right, is he in here today? Thank God. He's gonna get his dum-dum suckers, but he's not here. Ooh. All right, we got most of the data typed in. A couple people still typing. Yeah. All right, there, Scott. We'll wait for you. Yeah, we got Alora, we got Keegan, we got both Connors, Cindy, Skylar's here, Amon's here. Ami's hiding in the corner over there. She's probably tired of me giving her a hard time. What's up, Ami? Doing okay today? I'm here. I'm hanging out. It's a Monday. Jessica's here. Julia's here, right? There you are, Julia. I thought I saw you. Everybody's got the same look on their face with the mask. Sydney's here. Claire is here. Maddie is here. All right, got everybody. Okay, so now you got this into your calculator. Don't forget how to find what the correlation is. So what's my step? Somebody remind me, because Mr. G, watched hockey over the weekend and didn't pay attention to anything and brand new to the class. So what's my steps for finding my R value?
Oh, mine is already on.
Oh, yours is already in there? You got lucky. You found one somebody already used. What are my steps? How do I find my R value so I know what to do with this information? Yep, make sure the diagnostic is on. Very good, Skylar. And then what's my next step? How do I do that? I forgot.
Stat, calc, 4 or 8.
Very good. And then it'll show up, right? All right, so stat, calc, 8. All right, what do we notice about our R value? What do we see in front of us? You guys are sleepy today. What'd you guys get for your R value?
R?
Yep. What'd you get, Skylar? Since you're the only guy talking to me.
9999640.
So if we rounded it, lots of nines, right? 0.999999, almost a 1. So does this tell us that the ministers are causing an increase in the consumption of rum? What do you guys think? We got some yeses. Anybody think no? Can we say for sure that the increase of ministers is causing our consumption of rum to increase with it? Most people are saying it's pretty straightforward there. All right, well, let's look. So there's things called lurking variables that exist and that we don't account for. So very rarely in life are just two things causing each other to happen. There's usually something behind the scenes that we haven't considered, or things that we haven't put into our formula, and we're not going to in this class, but we need to be aware of those things we're going to forget. So a lurking variable is considered a different or outside variable that might actually cause both X and Y to change. It's sometimes labeled as a confounding variable or an extraneous variable. All three names mean pretty much the same thing. For this class, they are the same thing. And so what happens is we see a relationship that's very strong between X and Y, and our natural human brains want to sit there and say, oh, well, that's causing Y to happen. If I tell the ministers to move away from New England, then people will quit drinking so much rum, and that's it. That's my only solution. And we have to be careful, because it's not necessarily true that X is causing Y to change, but it is very, very strongly related to Y. So an example of a lurking variable in this particular format would be something like population increase. So if you remember the dates that were on the far left side of the chart, it started off around 1850 and it went to 1940. Well, something else was going on in New England between those two sets of dates, and that was an increase of population. People were just moving into Boston and all those states in that area. And so the need for ministers and the need for more rum both happen to be increasing at the same time because of that population. So what we have to be careful is with these lurking variables that we do not say a strong correlation actually implies causation. So Ms. Nichols wanted to make sure you could see it. Correlation does not imply causation. So be very careful. They will try to trick you with this on the AP exam, I promise. I'll sit there and I'll give you a very, very, very strong relationship literally between two things and say, all right, let's see which students paid attention. And so they're going to sit there and get you. If you have free time one time and you're finding any of this stuff to be of interest to you, you could click on this link later. We'll go through a couple of them, but not all of them. And it tells you or shows you a lot of correlations that are very strong but have nothing to do with each other. So for example, spending on science, space, and technology in the United States correlates strongly with suicides by hanging, strangulation, and suffocation. So if we just cut back on spending, right, less people will do that. No, that is not the case. They just happen to correlate strongly, but they are not causing each other to happen. Or number of people who drowned by falling into a pool and films Nicolas Cage appeared in. They correlates, it's just not causing each other. Okay, if I put all these numbers together, I'm going to get a strong R value. But we're not going to go tell Nicolas Cage to quit making movies so people quit falling into the pool and drowning. Because he's got nothing to do with it. Per capita cheese consumption and number of people who died becoming tangled in their bed sheets. Didn't know that was a thing, but apparently the more cheese we eat, the more likely it is to happen. But again, we're not saying it's causing each other. We're just saying they're related together. Or divorce rates in Maine by consumption of margarine. So as long as people keep their consumption of margarine low, we'll keep those divorce rates down. What's some other crazy ones in there? I know these have nothing to do with each other to show my point. Just because your R value is strong doesn't mean you have causation. People who drowned after falling out of their fishing boat and marriage rates in Kentucky. And very strongly correlated. They go right hand in hand there. So if we can just keep people from falling out of their fishing boat, we'll be good. What's another one that made me laugh? Japanese passenger cars sold in the U.S. and suicides by crashing of motor vehicle. So apparently when you drive a Japanese vehicle, you just can't help but drive it into a building. Again, in reality, would we say that those two things have anything to do with each other? No. So we know better. So these are things to watch out. There's a whole bunch of them on there. Spelling bee, championships, math doctorates, blah, blah, blah. Anyway, so you guys can check this out later so you guys can see. They correlate, they just don't cause each other. So you gotta be careful with your wording. So correlation means there's a relationship there, okay? Just like number of ministers and Cuban rum. There's a relationship there, but we're not saying one is causing the other one to happen. So just be careful with that stuff. All right, so that wraps up our stuff from last time. Elliot's making See, Elliot, all kinds of fun stuff you're gonna learn in this class. All right, AP statistics, day number 3. Let's talk about residuals and what that little R squared means on our data that we've been ignoring. So the coefficient of determination. All right, so what's a residual? We call this error. So as good as you are as a statistician, and you guys are awesome statisticians in the making, I promise. As good as you are, you're still going to make errors. It happens because, as we have learned, life does not follow a formula. If it did, we could predict the future. So what happens is when we make our predictions with our equation, we're going to have differences between what we expected to happen and what actually happened. So if I got my pretty little super graph here that I'm going to draw on the screen so you guys can see it. All right. And I've got this regression line. So Connor's done his job and he's got his LSRL all set up right here, nice and pretty. All right, and he's got his points kind of floating around here, and there. And, everything's just going. He's like, all right, I'm ready to start making my predictions, Mr. D. So he's going to come over here. He's going to find an X value that he wants to find out about. And his formula is going to spit out an answer right here. And this answer is his Y hat. Okay, we talked about this before. Now, in real life, his dot may actually be down here. All right, his actual answer. He just predicted this one, but his actual answer is here. So in between those two dots is a space, and this is called your residual. All right, so if you got space in between your actual dot, Skylar, and the one that actually happened, that's called a residual. Okay, it's an error. So to find your error, this formula right here is going to be your buddy. You're going to take your Y value that you actually have minus the one you thought you would have according to your formula. All right, your observed actual data minus your predicted one, and that's going to give you a residual, which again is the same as calculating your error, right? Like everything else in stats class, we have to interpret. So we would say that the actual, whatever your Y variable is whatever the unit you're using to measure, is either above or below the predicted value. And we're going to go through one of these in a second so you guys can see how it looks. All right, if my number comes out negative, so if I take the actual number minus the predicted number, so in this case, the actual number would be a smaller value than the predicted one, I'm going to get a negative number right here, so then that would be below. If I took an X value over here, like X number 2, and I thought, okay, it's going to be right here, I did my formula, but the dot is actually up here, then now we have a difference that's positive, so then we would be above. So negative numbers mean your actual value is below what you thought, and positive numbers mean that your number is above. And again, we're going to format and do our, our interpretation and all that stuff as well. So fun times were had by all. Now that we're getting into the advanced part of our, regression. All right, so in order to help us out with determining if we actually have some good data, we're going to create today in class what we call a residual plot. So it's another version of our scatter plot, but what it's going to show us instead of the LSRL is it's going to show us the differences between our actual answers and our predicted answers. So the purpose of this graph today will be to tell us if the model that you designed between your two data variables is actually appropriate fit or not. And so what we're going to look for is a residual plot with no pattern. If we see a pattern, then we know we have a problem. So there's two examples on your notes, and we're going to look at both of them in a second. If we have a pattern in our data, then on the residual plot, then there's an issue. So on your actual scatter plot with the LSRL, a pattern is okay. But on this residual plot, we don't want to see a pattern. And I pick on this kid because he was a good kid, but he asked a lot of questions about patterns in his residual plot. He was like, Sherlock Holmes looking for patterns. And so anytime 2 or 3 dots appeared to be, somewhat related together, he's like, is this a pattern, Mr. G? It's not going to be hard to find. Okay? Your residual plot is going to be very obvious. Ooh, I have a pattern, or, oh, no, I'm good. So you don't have to do a Where's Waldo search and try to decide if 3 random dots are making a pattern. You will know right away when you look at it if you have a pattern or not. Again, if you have your notes printed out and you're looking at them, there's 2 different examples there. The one on the right, it's clearly got a pattern. Okay, so let's look at those. Again, the purpose behind this residual plot is to see if the model that you're designing is actually an appropriate fit. All right, so you guys are becoming, like I said, good statisticians before your eyes. So we're going to go through an example here. Consider a population of adult women. We examine the relationship between their height and their weight. So we notice we have a bunch of little normal curves on our graph. And so what we do is design a best fit line that goes between them. So the reason why the picture looks like this is at the height of 60 inches, we would expect most of the women to be right down the middle of this normal graph. And then some of them are going to weigh more and some of them are going to be way less. Okay? Anything that has to do with human characteristics would be this way. We could do heights for guys, we could do weight for guys, whatever. Any characteristic of humans, we're going to have a majority of people that fall in the middle, and we're going to have some above and some below on whatever statistic we're talking about. So your best fit line goes right through the middle of this stuff, and understanding that you're going to have some points above the graph and some points below the graph. So what we do is we take a random sample of these women, okay, so a couple dots from the top, a couple dots from the bottom, make it as random as possible. And what we can see is now if I made a prediction of a woman who's 64 inches tall, I would expect her weight to be here, but she might be more or she might be less. Same for any of these X variables. So what we do for a residual plot is we take this data and we make it to where that line becomes horizontal. And now I can clearly see that I have a good portion of my dots above the line and a good portion of my dots below the line. If this LSLR is actually decent, if I did my job correctly, then this should be the kind of graphic I see over here in this graph, because we would expect some above and some below. It should be a balance. That's what your best fit line is trying to do. It's trying to minimize the distance of the ones up on the top and the ones at the bottom. We already went through that slide before a couple days ago. So this is the kind of graph I want to see if I have a good equation over here. So then I can go back and say, okay, I can continue to make predictions from this data. I'm confident that everything is working. So remember the other day we looked at, if our R value is kind of weird looking like a 0, we need to double check. Do we even have anything that's linear? If my data is actually not linear, I'm going to start to see a pattern in here. And that's going to be what I'm looking for. All right, so there's an example of 2 different ones. This first one, you have an appropriate model. Anything that looks like a bunch of dots have been squished up on your screen with no purpose behind them, then you're good. You want to see this. This is good here. If it starts to look a little bit more like a parabola or any other kind of weird graph shape over here, we've got an issue. This would not be an appropriate model. So if I ran my residual plot of my data and this came out, stop. Don't use your other equation. It's wrong. It's not working. Something else is going on with the data that we're unable to determine yet, so we can't use our LSRL with that data. And we're getting into some deep, heavy stuff here, so stop me if you guys got questions. All right, finding the residual plot on your calculator is very easy. You add like 2 steps in from what we've already done before. All right, so it's in your notes. You can write it down or take a picture of it if you're doing your notes by hand. We're still going to do stat. We're still going to do edit. You're still going to type in everything into L1 and L2. Nothing changes there. All right, and then Skylar helped us out, and he reminded us that you do stat, calc, and then either number 4 or 8 for your regression. Still going to do that. You're still going to go to the second button and hit Y equals to turn on your stat plots, just like we've been doing. You're still going to pick the first option. Now, where it starts to change is down here. Your X values will be L1, but your Y values are going to switch. We're not going to make them L2 for our residual plot. We're going to put in the option resid, and it's going to help us find our residuals. You can do this after you've done your linear regression. So if you don't do your stat calc number 8 first, it won't work. You have to do that first. After we get it typed in, and I'll show you guys where to find it here in just a second, it's not that difficult, then you can do your zoom number 9 and you can see your pattern. So let's practice. One measure of the success of knee surgery is post-surgical range of motion for the knee joint following a knee dislocation. Ow, that doesn't help. Is there a linear relationship between age and range of motion? So what I'm going to do is type in all of my data into the L1, L2 list. So go ahead and do that first. So ages should be your L1s, 35, 24, 40, etc. And range of motion should be your L2s. So if you need a calculator, grab it, type in your data here. All right, what we're going to do first is sketch our residual plot. So once you have everything typed in, we're going to be looking at how to do the residual plot in a calculator together. If you know how to do it from the instructions, you can go ahead and try to do it yourself. But I'm going to go over with everybody once they type in their data. Who's coming in? You know what I mean? Tired? Yeah, you know that. And type it in your data. Type it in, type it in, type it in. No problem there. If you got the internet issues, I'll keep logging you back in. No worries. I'm gonna try to record this video again, 6 period, because that one they have more people at home, so it's easier to do that one. And if you miss anything, you can go back and watch the video later today. Not a problem. I know the internet is never always working, you know, whenever we need it. All right, anybody still need the data? You guys are Superman. Everybody must have had like a fun weekend or something. Everybody's super sleepy. That or you guys work a lot. All right, let's look at my camera stuff here. All right, so I got my stuff typed into my calculator. All right, age, range of motion. Now, before I get all excited about making predictions, I want to check that my data is actually linear. I want to make sure that there's no pattern in my residual plot, or I'm going to be wasting my time. So we still got to do our first steps. We're going to do stat. We're going to go over to calc, number 4 or number 8. We're going to run through everything. Don't change this or do anything yet. If you want to put your equation in, you can. You don't have to this time. We don't need it for today. And then you do your stuff. So I see in front of me my equation, 107.5831 plus 0.8710 if I round it, x. So that would be my equation for predicting range of motion based on age. But is that actually a good equation? So we look at our R value here and we see 0.5534. All right. We're looking at a moderate positive relationship. There's something there. But before I start making predictions, let's make sure the line actually fits. So we're going to go into second, y equals, and then normally when you guys go into your stat plot, you don't see what I have on here yet because I didn't reset it from 0 period. Normally you see L1 and L2, correct? All right, so in order to change your y list to what you just saw on my thing, residual, you're going to go to second and then hit stat. What it's going to do is bring up a list of stuff, and the very last one is the one we want. So second, stat, and the very last one is the one you want, number 7. Yes, sir.
And the Y.
Yep, and the Y, you got it. So now I should say resid for residuals there. So now when I hit graph, and you're going to have to do zoom and number 9 on yours to get it to look like mine. When I hit graph, I should see this. Is everybody okay with finding this? Now, do we see a pattern here? So after you get it put in there, you hit graph, and then if you need to, hit zoom number 9. Do we see a pattern? I don't see a pattern. It looks like a bunch of random dots all over the screen. So, like I said, don't be the Sherlock Holmes like my other student was. He would sit there and be like, well, Mr. G, is this kind of parabolic? No, it's going to be very obvious. It's going to be right in front of you. Like, it's not going to be, hidden in the corner. So this is a non-pattern residual plot. This is what we want. So what that tells me is I have good data in order to make a prediction using age and range of motion. This is what I want to see. You got a straight line on here? Okay, don't change anything. I'm going to come over and look at it in a second. Okay, so this is a residual plot. This is measuring your points, how far they are above and below the line. That's what we want to see. So there's your sketch. Sketch it in. Let's see what you got, Skylar. So get this real quick. Hit enter. You want the first one to be L1 stuff. Go down to X list, hit second, number 1. No. Yeah, that's my first. Number 1? Yeah. You want that so that that one's okay that way. Now hit graph. Now hit zoom and number 9. Ta-da, thank you. All right, so you guys can see on your graph here, okay? No pattern. So don't try to be specific. And like that one guy was in my class, the baby sophomores are or whatever. And they get nervous. They want to show their senior friends they can handle the class. And so he was like overreading it. This is not a pattern. This is completely random, and that's what we want. That means I have a good relationship between my 2 data points. So I can continue to make predictions and be okay with it.
You said, is it literal, is it approximate?
Yeah, use the word approximate, for sure.
Approximate y is affected by y? Or it's the other way about
It is the actual y minus the approximate y.
Oh.
Yeah. So what I would do, Skylar, is not on this graph, but I'd have a dot that I would compare it to in a second. I can show you. So since there is no pattern in our residual plot, there is a linear relationship between our age and range. So some of you guys were asking last week, Mr. G, you're saying strong, positive, linear. How do I know that last one is linear? Now we know. This is our test. If this comes back to a pattern, it is nonlinear. This is why we can't use that. And we're going to do some of those next class, so just be ready for it. All right, any questions over the residual stuff before we move on to our R squared? Are we okay with this, Zoom people, class people, sleepy Monday students? Okay, so coefficient of determination. This is the other thing we're going to talk about today. So that was the previous thing was our residuals. We know how to kind of read them and look at them. And you guys should be able to kind of work through those on the homework assignments. We're going to do an example together here in just a second. So the what in the what? Hang on just a second. You have to show me. I'm a visual guy. Sorry, Scott. So now we're going to talk about the coefficient of determination. This is our R squared. So when you were doing that stat, calc and all that stuff, and you're doing number 8, you were always wondering, well, maybe you were wondering, most of you guys probably don't care actually, but you were wondering what that number right there is, that R squared. We're going to talk about that one. And so we know the R, we know the A and B. Let's talk about what the R squared stands for. So R squared, coefficient of determination. So this is the actual proportion of the variation in Y that can be attributed to an approximate linear relationship between X and Y. So that's a mouthful for a description there. What does the word variation mean? Somebody remind me of that one. Make sure we're all on the same page. Get some feedback from you guys. What does the word variation mean? And the class goes quiet. People at Zoom, help out my class here. What is the word variation? Anybody know variation? If I put the word variation in front of you, can you tell me what it means? I'll pick on my usual people. Yes, very good. And then like, you're right, Connor. And what would it tell me if the number was big versus if the number is small? Yes. And then same thing there. If that number was big versus small, what does that tell me about my data? Yes, very good. So showing the relationship and specifically, and you got it right, it's specifically how far apart it is from each other, right? And so that's what the word variation means. If I have a large variation or a large number for variation, my data is like all over the place. Okay? If I have a small number for variation or standard deviation, then all my stuff is really close together. And so what this R squared is telling us is how much of that variation in your data can be attributed to the relationship it has with X. Okay? So it remains the same, just like last time if we switch our X and Y, and it's also non-resistant, meaning it's affected by outliers. So if outliers get bigger, then the variation gets bigger, okay, which means the coefficient of determination gets bigger. So why use R squared and not just R? Well, R is measuring the actual strength and direction of the linear relationship. R squared is telling you how much of the change in Y is being attributed to the X and Y relationship. So sometimes your data starts to get more spread out because of the X values you're putting in it. Sometimes it doesn't. And so they're both very similar measurements, but they're both just a little bit different. All right, so we're about to talk about how to calculate the coefficient of determination. When I go through this stuff here, please remember that you're using the calculator. None of what I'm about to show you is anything I'm going to expect you guys to do in the class, but I want you to kind of see what is going on in the background in order to figure out this number, because for some of us, it helps to understand the why and not just the what. So we've got our age and we've got our range of motion and we've got our data, right? So if you guys were to graph all of these, take the residual plot off and put L2 back in there, your scatter plot would look like this. We didn't do it, but we took it off. And so suppose I don't know a future X value. So if I'm one of these doctors who's performing this surgery on a dislocated knee, and I don't know what age you're going to be when you walk in, I still want to give you an estimate about how much range of motion you're going to get after the surgery, right? If I'm a doctor, I want to give you kind of an idea. So I might say like, all right, Connor, you know, you bust your knee up in football, you're coming to see me. I don't know your age yet because I haven't gotten all your medical records. But in general, the kind of surgery I'm going to perform is going to give you about 130 degrees range of motion after. Now, a lot of factors are going to go into how much range of motion Connor's going to have. His age. Okay, older knees tend to not have as much range of motion as younger knees. His physical ability to begin with, okay, if Connor couldn't move his knees to begin with, I'm not a miracle worker. I can't suddenly make his knees brand new. All right, so a lot of factors are going to go into what his new range of motion is going to be, but as a doctor, I want to give my patients a general baseline of what to expect. And so what I could do is take all of the average, you know, all the Y values here, average them and see that, all right, my patients average about 130 degrees or whatever these, I think that's what these are talking about, range of motion for their knees afterwards. And Connor's like, okay, perfect. I just busted up my knee in football. Moving it at all makes me happy. I want to get back to play. Cool. All right. And so what I can do is see that I'm going to have some patients that are going to be below because they had physical things that I couldn't fix. And some patients are going to do even better because they just naturally heal better or whatever. All right. And so that's what's happening here when we do our average or residual plot. And so we would have what we call a total sum of squared deviations. So Connor was right on to the point earlier. That's what I'm picking on now. He was talking about taking all of those variations and squaring them and adding them up. And that's what all of these distances would be, 1,564.917. Again, not something I would ask you guys to have to do. This is what our calculator does. And so then I would sit there and compare that to, okay, now if I actually do know the X value, so Connor tells me, okay, I'm 18, right? Is that what your age is, Connor? 17. Okay, so he tells me he's 17. Now that I actually know his X value, I can plug it into my equation and say even more accurately now, hey, at this age, that's the average I expected to do. Whereas if somebody who comes in is 40, they're going to have a different number. Okay? Because as a doctor, I've seen a trend that certain ages have different responses, whatever that may be. And so I can create the formula, which we've done before, right? Our y hat 0.81. So this is everything that we did last class. And I can sit there and now say, okay, you know, based on where Connor's X value is of his age, so 17 is probably closer back here because we have 14 as the youngest. So he's probably back here somewhere. I can make a prediction of what his age is going to be, and then I can figure out how good my line fits here. This would be the sum of the squared residuals using the least squared resistance or regression line. And so this is a different number than I had before. The previous number was based on the deviations. This number is based on the residuals. So now, in order to figure out what that R square is, we would take the total minus the residual divided by the total. which is all these numbers, and we get 0.3026. Now, if you look in your calculator, what number did we get for our R squared? Boom. So you don't have to do the formula, but now you know where the number is coming from. It's taking all of the differences if I didn't know X, and it's taking all of the differences if I did know X. It's subtracting the two and saying this much of your Y's changed based on your X values. And what you get is a number that tells you how much your Y adjusts based on the X value that you know. And so it's a nice measurement on top of your R value to kind of see how strong your equation is. All right, so again, take these distances minus these distances, come out with this little factor there. Okay? Again, none of this you're gonna have to do by hand, so please don't stress that. I don't ever want you guys to have to do it. This is what we call our R squared, the proportion of variation in Y that is explained by its relationship with all the X's. So as a doctor, I can sit there and say, I've been able to explain about 30.6% of my Y values once I know your age. That's very helpful if I'm going into more advanced statistics and I want to make an equation. I want to know how effective age is as a predictor. Now we're starting to get to more of the, what is causing it versus just related to it. We can't say for certain that age is the only cause, but we can definitely start saying how much of it has effect. So here's how you interpret your R squared, because like everything else in class, we got to have a description. So we would say our R squared percentage. So for this problem, we would say 30.6% of the variation in motion can be explained by the approximate linear relationship between age and range of motion. So my R squared is telling me that 30.6% of my variables can be explained by that X variable. That's helpful. Okay. So that when Connor comes in and he's 17 and he's thinking about his football future and he's worried about his range of motion, I can say, hey, you're in luck. 30% of the time-ish, students that come in with this age, this is typically where they're at. Now we're happy. Connor's like, okay, I feel better now. Thank you, Mr. G. In fact, you're gonna make my knee work better than it did before. All right, then we go forward with the surgery. Again, it's still just a prediction. There's a lot of other factors, lurking variables and things behind it. Connor's original fitness. Did he work out really well and build his knees up, or were they already bad? The sport he plays, the things he's going to do with it. All that stuff's going to go into the thing. And you're never going to have all of the answers as a statistician. You can just keep adding. But luckily in this class, we're only ever going to do two things. We're not trying to stress you guys out with multiple linear regression. It's fun. If any of you guys are interested in seeing what it looks like, I have plenty of papers and projects you guys can look at. Again, I don't know where your guys' interest is at, okay? But I'm happy to fuel any statistical hunger that you're looking for. Okay, so how well does age predict the range of motion after knee surgery? I just kind of highlighted it, but 30.6% of the variation in range of motion after knee surgery can be explained by the approximate linear relationship between age and range of motion. So Skylar said use the word approximate, he was correct. You're putting the word approximate. So as a doctor, yes, with a little hat on it. Yes, sir. Very good. You got it, man. The Y with the little hat. So we're starting to get into some heavy stuff now. Everybody can do linear regression, type it into a calculator and looking at two numbers. Now we're starting to look at, okay, how well do these two numbers affect each other? A little bit. Again, it's only 30%. So 70% of that Y value is still determined by other stuff. What other stuff? I don't know. I'm not a doctor. So we could go talk to the surgeon and go, what other things affect range of motion? And we start plugging those in there. And that's where multiple linear regression. It is a class in its own, and it is a lot of fun. And if you like calculus, it's right up your alley. If you don't, stay away from it. You like calculus, Skylar? Have you done calculus for me? No. All right. Anybody in here taking calculus before? Did you have fun with it, or is it something you're glad you're doing? Yeah. There's some things I liked about calculus and some things I didn't need. Lots of integrals, if you didn't like integrals. I was a fan of derivatives. Those were easy. You didn't like derivatives? X squared becomes 2x, and it becomes 2. Like that was easy. Going backwards was the hard thing. How to change, x back into x squared by dividing. No, as I say, the integrals are a nightmare. I hated those things. Okay, so what you're going to do now is practice one of these on your own, right in front of you with your notes. I'm going to give you guys like 15 minutes to play with this, and then we'll go over the answers because this is what your quiz is going to be over. This is the stuff that's going to be on your test. So I need to know right now where you're stuck and where you feel confident. On your notes, real quick, if you printed off your notes and you look at the computer printout, see where it says pH and then the 197.694? On the screen, there's a negative in front of that. You need to have a negative there on your notes. It did not print off for some reason. It disappeared. So if you have your print off notes that I handed you or you printed them off before today, it's been fixed, but if you've done it before today, you need to go in there and add a little negative right here, Zoom people. Right where that pH 197 is, put a little tiny little negative symbol in there. Because without that negative, you're going to have some issues. So biologists are studying, again, the effects of acid rain on wildlife collected from data of 163 streams. So instead of making Connor type in 163 data points, we went ahead and gave him a computer printed output. So see what you remember about how to read these, create your equation, interpret your slope, find your R squared, find your R, calculate a residual at that X value, interpret your residual, and see if you can figure out the actual measurement if I give you the residual. See how far you can get. 7 questions, 15 minutes. Again, if you need to get a drink or anything in class, you guys feel free to go down and grab one while we're doing it. Your turn to play. Zoom and people in class, if you get stuck on a question, circle it so we can go over it for you. And go on to the next one. Zoom, if you guys get questions, you can type them in the chat if you don't want to say anything. Laura, I guess, at the desk or like we're working to stare down the window. People look other than that. Still saying Connor and Stephen saying. What's that? No, sorry. No problem. I'll stay out of your way. You need you want to look at one of the other ones? No. You good? Okay. All right, about 5 more minutes. If you guys are looking for them, all of the sentences that you would need to write are at the very bottom, which is summary of interpretations. Basically, just plug in your information. You ready this one?
Yeah.
Cool. Yeah, if you guys will wait, and you can always look through the homework stuff or whatever. All right, about 2 more minutes. Got a couple people still thinking and writing, so I don't want to rush them. This is very, very, very similar to what your quiz will be. Practice quiz will be on next class, Wednesday. All right, so let's go through these. Stop me if you got questions or you're unsure about stuff so we can explain it if you circled any of these, especially those of you guys at Zoom. I haven't gotten to walk around, obviously, and look at what you guys have, but in class, it looks like most people are getting it pretty good. But if you don't ask for help, then I don't know where you're getting stuck. All right, so when you get a computer printout like this, a couple things to remember before you start going too crazy. These 6 numbers over here on the right side, don't let them distract you. Okay, for sure, don't let these distract you. So, cross out the T and the P value stuff. You don't need that. Remember, we never use the R squared adjusted, so you should cross that out or get out of your way because you don't want to use that one. And you really don't need the standard error coefficients right now. Okay, so all of these things are not necessarily needed. You really just need this number, and you need that number, and you need that number. Those are the 3 things you need. So when you're writing your equation, it comes from these, and then your S. Yeah, you don't need your S on this one. So those are the 3 things you need. All right, so don't get distracted with the computer printout. There's a lot of information being presented to you. Not that this stuff is not important. It is very important information. We're just not to that point yet. All right, so for number 1, what is the least squared regression line? I got 2,733.37 minus 197.694. If you did plus and negative, that's the same thing. And don't forget to define your X and Y, where X is the pH and Y is the BCI in streams. I'm not a biologist, so I couldn't explain to you how BCI is measured, but there it is. That's the luxury of being a statistician. I don't need to know what the things stand for. I just need to know their relationship. So that's number 1. Number 2. Or sorry, I guess we skipped ahead to number 3. So find and interpret the coefficient. There you go. Put both of them there. So number 2, when the pH increases by 1, the predicted, right? So again, approximate predicted. Skylar was very helpful reminding us that earlier. BCI decreases by 197. You need to put the word predicted in there. If you're not saying for sure that's happening, you're saying by your guess. Now, normally, like 99% of the time we do these problems, there's going to be units, feet, inches, miles, grams, ounces, whatever. Not on this one. Both numbers just happen to have no units. It's the way this worked out. So that's okay. You don't need to put any units on there. But if there were units, you would want to include those. And then number 3 says to interpret the coefficient of determination. So that is your R squared. So that number is 0.271, meaning 27.1% of the variation in BCI of streams in the Adirondack Mountains can be explained by the approximate linear relationship between pH and BCI. Whew, that's a mouthful. Yeah, the least squared regression line is doing kind of the same thing, but what this is telling us specifically, Skylar, is how much of it can be attributed to the X values you're plugging in there. So if you go back a couple of slides, I'm not going to do it, but if you go back a couple of slides, there was all those least squared and all that stuff. It's a percentage, yes, sir. Yes, R squared becomes a percentage. Now you can take your R squared and find your R. So we take the square root of 0.271 and we get negative 0.5206. How do I know it's negative? The slope is negative, very good. And that was missing on the paper. So if you didn't write that down as a negative slope, then that's our bad. But if the slope is negative in your printout, then the R value is not gonna match it. Because remember, when you take the square root of an answer, can you tell if it was originally positive or negative? No. All right, so it's negative because the slope is negative. There is a moderate negative linear relationship between pH and BCI of streams. Now, I know I just got done teaching you how to look for patterns in your residual plot. So we're going to take their word for it here that it is linear because we can't do that in this case. I don't have the 163 data points in front of me. I also don't have an R value that's 0 and a weird R squared number very low either. So I'm going to be good to go. All right, questions on 1 through 4. All right, the hardest part for me, and this might be the same for you guys, is remembering the difference between these words. Coefficient of determination, R squared, correlation coefficient, R. They sound very similar. It's going to take a little practice. Otherwise, you guys, I think, know how to use them. Walking around, I saw very good answers. So, Zoom people, same thing. Just be aware of the different names. They sound similar. Lots of coefficients everywhere, apparently. There's swimming in coefficients. All right, number 5. Calculate the residual if your pH of a stream is 7.2 and the actual BCI measurement is 1298. So here's where you take your equation. You plug in 7.2, and it's going to spit out, I got, where did I put my number? 1,309.9732. Yeah, there it is right there. So then I take my actual number, the 1298, minus what my equation said I should have gotten. So like Skylar again said earlier, y minus the y with the hat on it. And that gives me a negative 11.9732. It's very important you watch your symbols here. because the negative is telling you that your actual measurement is below where you thought it was going to be. So now that's what you use for your interpretation. The actual BCI for this stream is 11.9732 below. How do I know it's below? It's negative. The predicted BCR for this stream. Again, at the very bottom of your notes, if you printed them off, it's a very, very helpful little like strip of information that has all of these interpretations. You just plug in your information. Keep this handy with you whenever we take our quiz and test. It'll save you. Because if you're like me, memorizing things, you know, it's hard. The brain's getting full. All right, number 7. For the residual of a certain stream, it's 15.2 and the pH is 7.8. What's the actual BCI for this one? So we're using algebra. We're working in reverse. So we know that if we plug 7.8 into our equation, we're going to get our predicted value of 1191.3568. So now I can go over here, and I know the residual between the y and the minus y hat is going to be 15.2, so I plug that in for the residual amount. I'm looking for the y, and this is negative, so basically it's simple addition. Take this number, add it over to this number, and you get 1,206.5568 is the actual measurement. So sometimes you just know, hey, we got an error of this much. What was our actual number again? And you can do it in reverse. That covers today's stuff and what's going to be on your quiz next class. So questions for me. Now's your chance. Put me on the spot. See if I know my answers. All right, again, I get very excited about this stuff because this is like my livelihood and this is the things I like to do. So if I went too fast or I didn't explain things in a way that made sense to you, make sure you stop me, ask me, see me in tutoring, whatever, so that I can slow down, relax, and actually, you know, explain it without getting too excited. Like I said, if any of this stuff is interesting to you guys and you want to see where it leads further as a preview, always let me know. I'm happy to show you some of the things I did at college level. Not as a bragging thing. I was not the best college student, but because I get lazy. But I'll show you some of the work that we had to do. If this is something you're like, well, this is kind of cool. We're starting to get into some, you know, like actual analysis here, and this is what I signed up for. Then, like I said, let me feed that because statistics is a nice, high-paying job, especially if you decide not to teach, like me. Then you can go on to go do something for like sports or medicine or something and make a ton of money. In fact, I got an email from a student who's doing biological medicine studies, and said that this class has helped her first 2 semesters in college go by like real smooth because of all the stuff that they use in medical field. So anyways, those are student accounts, not me making up stuff. That's it for today's lesson. Don't see any questions on Zoom. Don't see any in class. So just as an action item reminder of what is due before next class. So you've got your homework packet, all right, or these are at least available on Google Drive when you click on the link. The first 3 pages are what are due. So you got worksheet number 1, worksheet number 2, and worksheet number 3. So you've got until Wednesday before our quiz to get these turned in to that very first spot. So where do I turn these in, Mr. G? Go into here to, where we at? There we go, regression. Go into modules, and you'll see it right here. Scroll down, regression worksheets, 1 through 3, turn in. Boop, just pop it in there. Make sure you're not using HEIC, Apple users. I know it's a very nice, clear, pretty picture. It does. It is a great picture. But the computers we have here at school do not like Apple, and I can't load it up unless I go home. And if I got to go home and grade it, I might forget, and then you get a missing grade. So do not use HEIC format when submitting. PDFs, docs, sharing me your Google link, all that stuff is fantastic. But for whatever reason, we do not like Apple links on our computers here. Don't know why. I've tried to install codecs that will let me look at it, and it cusses at me. So I apologize if you have an Apple phone. Just make sure you're using the different format than HEIC. If it says that, it will not load on my screen. That's all I got. You guys have a good day. Zoom people, we'll see you on Wednesday for our quiz. You guys in here got like 18 minutes. You can work on whatever. You need to use the restroom, grab a snack, or whatever you can get to.